guys, and welcome to a new video. In this video we are going to solve some integrals. Okay, so the first integral is the following. We have the integral of x times e raised to the power of x squared dx. Okay, so in order to solve this integral we can change the variable. So now the variable of the integration is x, obviously, but if we want to change, it is convenient to change the variable considering a new variable. Let's call it for example t, such that t is equal to x squared. Okay, so that means that here, for example, we will have e raised to the t, and then here we have x, and we have also to change here the x. So in order to do so, we have to consider the derivative of t with respect to x. So we have to consider the t over dx. So here basically we are considering the derivative of this variable with respect to the old variable, let's say. But since we know that t is equal to x squared, the derivative of t will be the derivative of x squared, and we know that the derivative of x squared with respect to x is 2x. So that means that basically the t will be 2x times dx from this relation. Okay, so now to compute the integral, we basically have to consider all these calculations that we did. So since here we have x and dx, and we know that the t is 2x times dx, here basically we can multiply and divide by 2. So here we will get 1/2 the integral of e raised to the power of t times the t, because 2x times dx is the t. Okay, so here we now have to compute the integral with respect to t, but we know that the integral of the exponential function in this form is the exponential function. So that means that this integral will be 1/2 et plus c, where c is the constant of the integration. Okay, the second integral is the following. We have the integral of cosine of the log, the natural log of x dx. Okay, so in this case also it is convenient to consider a substitution, so it is convenient to change the variable, and in this case we can consider a substitution of this kind. So t is the new variable, and we say that t is equal to the natural log of x. Okay, so by considering this integration, here we will get the cosine of t, but now, as we did in the first integral, we have to consider also the derivative of the new variable with respect to the with respect to x, so with respect to the old variable. Okay, so the derivative of t with respect to x is the derivative of the log, the natural log of x with respect to x, which is 1 over x. So that means that dt over dx is 1 over x, but this means that dx is x times dt. But since we know that t is the natural log of x, we can say that x is e raised to the power of t. So here we can say that dx is e raised to the power of t times dt. Okay, so having said that, we can substitute the variable in the integral. So as we said, t is the natural log of x, and we know that dx is e raised to the power of t times dt. So here we can write times et dt. Okay, so now we have to calculate this integral cosine of t times e raised to the power of t. And in order to solve this integral, we know that we can consider an integration by parts. So in order to do so, we basically let me write again the integral here. So cosine of t times e raised to the power of t dt. Okay, so we can consider, as I said, integration by parts. So in order to integrate by parts, first of all, we basically have to find the antiderivative of e raised to the power of t. But the antiderivative of this function is this function as well. So this will be cosine of t times e raised to the power of t. And then we have minus the integral of the derivative of the cosine, which is minus sine. So here we will get a plus sine of t times e t dt. Okay. Okay, so it seems that we didn't solve anything, but actually we can consider again an integration by parts. So we can consider an integration by parts of this integral, because if we write again this, so et cosine of t, and then we consider an integration by part of this, we get plus et sine of t minus the integral of et times cosine of t dt. Here, as we did previously, basically we found the first term by considering the antiderivative of this function, which is et, times the other function minus the integral of et and the derivative of sine of t, which is cosine. Okay, so here basically we found that this integral is the sum of these two functions minus the integral again. So we can write that we basically can write that this integral, which we can call I, so I is et cosine of t plus et sine of t minus the integral. Okay, as we are calculating I, we can write that 2 times I is et times cosine of t plus et sine of t. Okay, and also sort out et and write sine of t plus cosine of t. Okay, so here basically we can say that I is 1/2 et times sine of t plus cosine of t. So we found the value of our original integral. So we know that the result is this one, and now we have to basically change again the variable. So here the result is in terms of t, but we want the result in terms of x, and we know that t, as we said, is the natural log of x. So that means that the integral, so the result will be 1/2 e raised to the power of natural log of x times sine of natural log of x plus cosine of log of x. And we know that this is just x, so here we can also write simply x. Okay, and obviously I have also to write plus c also here. Okay, I just realized that here in the first exercise I didn't change the variable, so we can make it now. We said that the result is 1/2 e raised to the power of t plus c, and we know that the substitution was t is x squared, so here simply we have to consider 1/2 e raised to the power of x squared plus c. Okay, so this is the final result of the first integral. Okay, so the last integral is the following. We have the integral of sine of x squared in the x. So here we have the sine of x all squared. Okay, so this integral, we can solve this integral by considering the relation of sine of x with cosine of 2x. So we basically know that sine of x is plus or minus 1 minus cosine of 2x over 2 under square root. So here basically with this relation we can change the angle starting from 2x going to x basically, but here we have sine squared of x. Here the sign of this function depends on the value of the angle, but actually here we have sine squared, so here basically the square root goes away, so we know that the sine squared of x will be 1 minus cosine of 2x over 2. Okay, so we can consider this relation to solve the integral. So if we consider this relation, the integral will be we can write 1/2 1 minus cosine of 2x dx, and we are able now to calculate the integral, because the integral of 1 is simply x, and we also know the integral of the cosine, which is sine, and we have to be careful with this 2 here. So here basically this integral is just 1/2, as we said, times x, because negative you get 1, and then the sign becomes cosine, and then we have these 2, but we have also